All right, today we're diving straight into the front lines of a really tough battle, the fight against lung cancer. And we're going to explore how a powerful new ally, artificial intelligence, is basically getting trained to see what even the most expert human eye might miss.
So, to really get a sense of the stakes here, we have to start with this number, 1.76 million. Yeah, according to the 2018 GlobalCan estimate, that's how many lives are lost to lung cancer every single year, worldwide. It's the most frequent and, tragically, the deadliest form of the disease.
I mean, that scale is just staggering, right? And it forces us to ask a really crucial question. With an opponent this formidable, how can we possibly fight back more effectively? Well, the answer, as it turns out, starts with understanding the limits of how we currently see the enemy.
Okay, so let's dig into that. Because to really understand the solution, we first have to get a handle on the problem. And the problem is this. Lung cancer is just incredibly difficult to spot accurately, especially in its early stages. You know, our own vision, it has limits. And this, right here, is the absolute core of the issue. The earlier we can diagnose it, the earlier we can intervene, the better the chances are for survival. I mean, everything hinges on catching it early. But here's the catch. Our best tools, while they're pretty good, have some really serious drawbacks.
So let's take a look at the current toolkit, right? You've got CT scans. They're the gold standard, but they come with harmful radiation and, frustratingly, a high rate of false positives. Then there are PET scans, which are more sensitive, but they're not quite ready for widespread use. And MRIs? Well, no radiation, which is great, but they're costly, they take a lot of time, and they can actually miss those tiny little nodules. So at the end of the day, all of these powerful methods, they still rely on the trained eye of a radiologist to tell the difference between a harmless spot and a deadly threat. And let me tell you, that is an incredibly challenging task.
Okay, so this is where a new player enters the scene. I mean, if the biggest challenge is all about detection and interpretation, you have to wonder, what if we could build a tool specifically for that job? Well, folks, that is the promise of artificial intelligence.
What we're talking about here is something called a computer-aided detection system, or CAD for short. And the best way to think about it is like an incredibly sophisticated partner for a radiologist. It's basically software that's been trained to analyze medical images and flag anything that looks suspicious. It's offering this data-driven second opinion to help catch things that even a brilliant human might overlook.
And believe me, this isn't science fiction. A 2022 paper from the journal Cancers put it perfectly. These deep learning tools are already helping clinicians detect and classify lung nodules more accurately and way more quickly.
Okay, so that all sounds great, but how does it actually work? Like, how do you teach a computer to see cancer? Let's get into the nuts and bolts and break down the process, from the moment a patient gets a scan all the way to a final prediction. Okay, so what you're seeing here is basically the entire roadmap. It all starts with a patient scan. That image gets processed and fed into a deep learning model. And after all that training and testing, the whole workflow spits out the final prediction you see on the right. Is this little spot malignant or is it benign? Now this looks complex, but let's boil it down to 3 key steps.
Really, it all comes down to 3 fundamental steps. First, you have segmentation. That's just outlining the lungs. Then there's detection, which is finding the nodules. And finally, you have classification, figuring out the threat.
So, let's start with step 1, segmentation. You got to think of this as the foundation for everything else. The AI essentially draws a perfect digital outline around the lungs in the CT scan. It's a really critical first step because it filters out all the noise, the ribs, the spine, all that stuff, and it basically tells the system, hey, focus only on what's inside this line.
And how good is it at this? Well, some of the latest AI models out there are hitting an accuracy of 99.27% on this task. That's just an incredibly precise and reliable first step. Almost perfect.
All right, next up is detection. So now that the AI has its search area defined, it scans through, pixel by pixel, looking for anything that might be a nodule. It's basically a pattern recognition job on a massive scale. It's been trained on thousands and thousands of examples, so it knows exactly what to look for. All those telltale shapes, sizes, and textures.
And the performance here is all about something called sensitivity, which is just a fancy way of asking, how good is the AI at finding what it's supposed to find? Well, some of the top models are showing a sensitivity of 94.2%, and with a very low rate of false alarms. To put it simply, it almost always finds what it's looking for.
And that brings us to the final, and you could argue the most important step, classification. Okay, so the system has found a potential nodule, Now comes the moment of truth. It analyzes every single feature, the size, the shape, the density, the texture, to make that absolutely critical distinction. Is this thing harmless or is it cancerous?
So, just how accurate is this final judgment? Well, some advanced models have shown a classification accuracy of up to 99.7%. Just let that sink in for a second. That is an absolutely astonishing level of precision. And think about what that really needs. It could mean fewer false alarms, way less anxiety for patients, and maybe even a reduced need for those risky, invasive biopsies just to confirm a diagnosis.
So, if we go back to our roadmap, you can see the end result. After all that complex, digital heavy lifting, the system delivers a really clear, actionable result for the doctor. In this final step, it classifies each nodule it found. This one over here gets flagged as malignant. That needs immediate attention, while this other one gets tagged as benign. It's providing that powerful, data-driven second opinion.
I mean, this technology is clearly revolutionary. But you know how it is. With any major leap forward, there are always hurdles to clear before it can become a standard tool in every hospital. So let's talk about the road ahead.
And really, it's a story of two sides. On one hand, you have the promise, which is just immense, right? Incredible accuracy, objective, data-driven analysis, and the potential to catch cancer earlier than ever. But on the other hand, the problems are very real. These AIs need massive amounts of data to learn. They can be a black box, meaning we don't always know why they made a certain decision, and a model that's trained at one hospital might struggle with scans from a different one.
So to turn this from amazing research into a clinical reality, scientists are focusing on solving these key issues. First, we just need bigger and more diverse data sets for training. We also need to build models that are robust enough to work on any scanner in any hospital. We've got to crack open that black box and make the AI's logic more transparent so doctors can actually trust it. And probably most important of all, this whole thing depends on a really close partnership between the computer scientists building the AI and the radiologists who will be using it to save lives.
So, what's the final takeaway here? Well, the accuracy is pretty much undeniable, and the potential is just breathtaking. Now, this isn't about replacing the incredible expertise of a human radiologist. Not at all. But AI is absolutely poised to become one of their most powerful, most essential tools, completely changing the front lines in the fight against lung cancer forever.